Hello friends, in my this video I am going to discuss how to generate echo in Matlab. Okay, so see, this is one system for which input is x of n is one audio signal which after passing through the system h of n, that we don't know what is the equation of h of n, later we will discuss about that, we can get in the output side y of n, which is basically consist of the input original signal x and its echo. Okay, echo means nothing but delayed version of original signal, right? Okay, if one signal directly come to your ear and another signal which is basically that signal only, but with some delay if comes to your ear, then you will feel that as echo, right? So based on this concept we will try to define the mathematical expression of h of n, and from there we will determine the Matlab code. Okay, so step 1 is form the difference equation of h of n. So as we know that in echo there must be presence of original signal, so y of n should be equal to x of n. Obviously x of n, one component must be x of n. Another component is delayed version of x of n, right? Because I told you in echo there is original signal plus delayed version of that signal. So like that, y of n is equal to x of n plus x of n minus d, where d is the d indicates the delay of the main input signal x of n. Now you tell me whether you get the delayed version as same intensity as of original signal. No, the delayed version in echo consists of lesser sound, right? That means it should be attenuated. So what we will do, we will multiply alpha, which is basically a factor which is less than 1, that may be 0 0.1, 0 0.2, 0 0.3, whatever, that means in between 0 and 1, but it should be less than 1. Okay, we will multiply this factor alpha with the delayed version of our main audio signal. Okay, so basically in this way, from the basic concept of echo, we derived the difference equation which relates the output y of n and input x of n audio sequence, that is basically y of n equal to x of n plus alpha into x of n minus d. Okay, now see what is the next step. We have to pass, so h of n we have to determine. That means if in terms of z domain we can say h of z we have to determine, that is numerator and denominator. If we able to calculate for this h of n, then we can simply apply the filter command to get the output y of n from the input x of n. Okay, so basically, so now we have to take the z transform of this and we have to get the numerator and denominator coefficient of the transfer function h of z, right? So basically, to make the derivation simple, let us first assume some values. So let alpha equal to 0.1 and this delay d equal to 1. Okay, so basically we can get y of n is equal to x of n plus 0.1 into x of n minus 1. Now you take the z transformation and tell me what is the answer. Y of z equal to x of z plus 0.1 into x of z into z to the power minus 1, right? Because you know that the z transform of x of n minus 1 is x of z into z to the power minus 1. Okay, so basically from here we can derive that h of z equal to 1 plus 0.1 z to the power minus 1, right? Because y of z is equal to, take common x of z in the right hand side and you will get y of z equal to x of z into 1 plus 0.1 z to the power minus 1. That will result into y of z by x of z equal to h of z is equal to 1 plus 0.1 z to the power minus 1. That means in simple words, numerator coefficients will be 1, 0.1 and denominator coefficient will be 1, because there is no denominator, right? Only numerator. If you want to simplify, you can simplify keeping z to the power minus 1 as 1 by z, then you take LCM, you can do. But in this way also you can define, that is numerator equal to 1 plus 0.1, sorry 1 comma 0.1 and denominator equal to 1. Okay, now let us take some more delay. Okay, instead of 1 unit delay, let us now take 2 unit delay. So y of n is equal to x of n plus 0.1 x of n minus 2. Why I am taking more delay? Because suppose you take simply one sample delay, then you cannot differentiate in between original signal and the delayed version of the signal. Those will appear as same because our processor works at gigahertz range, so significant amount of delay we should provide, then only we can differentiate in between our main input and delayed input, otherwise we cannot differentiate. So our intention is, what is the numerator and denominator coefficient if we increase the delay? That's what I am discussing, so that I am increasing the amount of delay. Now the equation will be y of n is equal to x of n plus 0.1 x of n minus 2. Similarly, if you take Z transformation, you will get y of z equal to x of z plus 0.1 into x of z into z to the power minus 2. Right? Now you calculate what is the numerator and denominator coefficients and tell me. Obviously, right, y of z equal to x of z plus 0 into z to the power minus 1 into x of z plus 0.1 into z to the power minus 2 into x of z. So that numerator will be 1, 0, 0.1, denominator will be 1. Often students mistake in this line. See here how I have written, after x of z there should be term of z to the power minus 1, but in this equation that is not present. So what we have to do, we have to make x of z into z to the power minus 2, directly it is coming, so that we have to make this term, that is 0 into z to the power minus 1 into x of z. Otherwise Matlab will not understand. If you simply write from this equation y of z is equal to x of z plus 0.1 into x of z into z to the power minus 2, if you directly write the numerator coefficient as 1 and 0.1, Matlab will understand that then what will happen, the Matlab will understand 0.1 coefficient as coefficient of z to the power minus 1, right, like this in this equation what Matlab has understood. But to differentiate in between these two cases, we should add the 0 in between these two terms, that is 0 into z to the power minus 1 into x of z. I hope you have understood this. Simple things already I have explained in my previously DSP playlist videos, you can check there. So numerator equal to 1, 0, 0.1, denominator equal to 1. Now increase more delay, then what you can get? Suppose let us take now x of n minus 3. So y of n is equal to x of n plus 0.1 into x of n minus 3. So y of z will be equal to x of z plus 0.1 into x of z into z to the power minus 3. So after x of z, directly z to the power minus 3 comes. So we have to arrange in this way, h of z equal to 1 plus 0 z to the power minus 1 plus 0 z to the power minus 2 plus 0 z to the 0.1 z to the power minus 3. So numerator coefficients will be nam equal to 1, 0, 0, 0.1, then equal to 1. Right? So basically the basic idea is denominator equal to 1 only, but numerator will be see how it is arranged, 1 and 0.1. What is 0.1? See what is 0.1? Try to understand. 0.1 is nothing but this alpha we have assumed. See, y of n is equal to main equation, mother equation is y of n equal to x of n plus alpha into x of n minus d. Instead of that, to make explanation simple, we have assumed the alpha value as 0.1. So basically see, this alpha value is appearing at the last. See how? See 1, 0, 0.1. So alpha value is appearing in the last. First term is 1 only, but in between 1 and alpha there are some zeros. Okay, and these zeros, if there are more number of zeros, that indicates that the delay is more. If there are lesser number of zeros, that indicates delay is lesser. Now, so basically we can conclude that numerator coefficient will be 1, then some zeros, then 0.1, right? Here 0.1, if you generalize, you will get alpha, right? So basically num will be equal to 1, then zeros, the sequence length of zeros depends on how much delay we want, and then alpha equal to your choice. 0.1 if you take, then it will be very much less attenuated, so better to take higher values of alpha like 0.9 or 0.8, like that. Okay, so with this basic concept, let us go to Matlab and let us try to write one code. So first let me open the editor window. First let me warm up the Matlab. 2 plus 3 5, 5 plus 6 11, fine. So these things you should do before performing one bigger code, simulating one bigger code in Matlab. So first step, obviously these things you should know, that how to burn or how to first install one audio signal in Matlab. So first of all, first step is define the sampling frequency. I have taken high sampling frequency to perform oversampling. There is no issue. So see, already previously I have installed one audio signal, that is example, in desktop. So F is defined. Now here, see here, this icon you can see, just click this icon. So you should select the folder of your choice where the audio file is there. So I have chosen desktop, then select folder, then see in the workspace desktop is opened. Now you just scroll below and see here you can get our mp4 file, that is example.mp4. Now write y equal to audio. What do you have to make? First you have to read the audio file, right? So audio read, then tell me what is the name of the file, example.mp4. So colon means that you have to write the name exactly, example.mp4, then quotation complete, then semicolon, right? Now p equal to play the audio, you should write audio player. Okay, audio player y comma sampling frequency f. Okay, now first let me copy this code and copy and then paste in the command window and click enter. Okay, it will take some time to burn. Now play p. As soon as I will click enter, the original sound will be played by Matlab. Just listen to that carefully. Click enter. Let me stop this. It is sufficient for our purpose. So stop p is the command to stop a code. Now what we have to do, num equal to what was our numerator, 1. Then to make the audio signal as echo, we have to give lots of zeros, and I told you that our processor works in gigahertz, so we should give a large delay. Large delay means larger number of zeros. So zeros, you know that zero command will make zeros. Let me take 4800 zeros, and then take alpha value. Alpha value you should take close to 1 but not 1. Okay, why I have taken? So that attenuation is not very less that you cannot listen that. So alpha equal to 0.9, then is simply 1, right? Now filter the signal. X equal to filter num comma den comma our original signal is y, so y. Clear? Now p1 equal to audio player x comma sampling frequency. I hope up to this it is done. Now copy this, paste it in command window, click enter. Again it will take some time. Let us check. Yeah, now listen to, now P1 contains the signal with echo. Now you listen to this signal and you will understand that yes, there is echo. I hope you have identified the echo part. So let me stop this. Now if you want to change some more, then you just increase the delay and you can change the attenuation factor according to your choice. In this way you can play with Matlab. So evaluate selection. Again it will take some time and then let it come. Now play P1. See, now the echo signal is different from the previous case. So this is how you can generate echo in Matlab. For better easily understanding purpose, you can use headphone so that you can listen to that echo easily, and you can choose your song according to that. First burn it in Matlab using audio read, then to play audio player Y comma F, and then you have to play P, you have to write to play that, to stop that stop P, and numerator and denominator, how it is defined from the concept of echo, that is important. After defining numerator and denominator, that is very simple. Just you have to use filter num then y, which you already studied in your DSP Matlab lab courses, right? So this is how you can generate echo in Matlab. This is all for my this video. Thank you for watching, and for more videos related to electronics and communication engineering, please subscribe my channel and don't forget to press the bell icon. Thank you.